Welcome to Room 2, Session 2, Day 1 of PyCon Indonesia 2020. My name is Scikit-Learn and I will be the moderator for this session. I would like to introduce the speaker for this session, Nick Doiron. Nick is a software engineer at Tufts University, web developer and mapmaker, previously at Code for America, McKinsey, and Museum of Modern Art. In the session, Nick will deliver a talk titled Is Your Data Fit to Fit Function? This talk covers all of the steps to clean, balance, and process your training data before you fit your model. In this talk, Scikit-Learn. For the participant, you can ask questions using Hopin chat. Without further ado, the stage is yours, Nick. Let's give a big round of applause to Nick.
All right, yes, thank you. Thank you for introducing me. Thanks for having me. Let me see if I can share my screen. That should be my slides there. Excellent. Yeah, so I'm going to be talking about, is your data fit to fit? I previously worked as a data scientist at McKinsey, so we had a lot of financial data, real estate data that we worked with, and had these very large tabular data sets. So I'm coming from that mindset and discussing the importance of how important it is, even before you run Scikit-Learn or some machine learning algorithm, to make sure your data is ready to enter that. Here's the agenda I have for the talk. First, just what is Scikit-Learn? I think that's the best way to get started learning how to do some data science, machine learning type work. It's not using neural networks, but a lot of the techniques that I talk about here are also used in deep learning neural network projects. We're going to have a list of common issues that people have with their data sets. And then I have a section about like fixes that I recommend, or different techniques I recommend for people to resolve issues with data sets. And then just so it isn't like, here's a problem, here's a solution, that kind of stuff, I have some slides at the end that are interesting about feature engineering, some stuff we did with geospatial data. And I'm going to be talking and not see the chat. So if there's a message in the chat, please, if someone can notify me somehow, please let me know. All right, so data science, AI, machine learning, they're huge industries, and they virtually, Python is definitely the most popular language. And right now, kind of the biggest hype is around deep learning. And if you're dealing something that's like with images, video, some kinds of text problems, absolutely go and send that to somebody who's the deep learning expert. But when you're first getting started, or when you join a company that has spreadsheets full of data, the things that still work very well, or even better in some cases, are on tabular data in tables and spreadsheets, is to use standard statistics and machine learning algorithms. And so that's why I've centered this talk around Scikit-Learn. There's a very good amount of documentation. If you Google something, there'll be someone who's gone down that road before. And you might say, oh, well, all these papers are about deep learning. Actually, everybody has tabular data. If you look into employee records and student records and financials and real estate, everything has been stored in a standard database or in spreadsheets. That's tabular data that you could use for this kind of project. Also, because it doesn't require like a GPU or anything to run, you can run it very quickly and locally. And then I don't get into it in this talk so much, but some algorithms in Scikit-Learn are interpretable, meaning if someone says, why did it say that this is a positive review and this is a negative review, you can have it actually highlight which words were responsible using more direct interpretability compared to neural networks, which are kind of like a black box. Now, If you have this tabular data and you're wondering, how does someone start thinking about it as a machine learning problem? Here's what someone might do. So you have your original data set on the left, and you split it into two parts, training and test data. There's several different ideas of like how the split should be done. But in this case, just think about this. You bring in the data, you take out some data to be the training data, and then it's going to run through. You select one of the Scikit-Learn algorithms to fit your data on. This is where you actually call the fit method, and then you're able to predict things with it. And then you wonder, is the prediction actually working? And the best way to know if it's working is you took out some test data. Usually about like 30% of your data is like taken out, and then you evaluate, are the predictions of your model working? And there's several different things where people have talked about, which scikit-learn algorithm do I use, which kind of problem. You can find lots of resources about that. But if you're getting started in this data science skills world, the area that kind of actually should get more attention is this step here, where you have training data and you're going to put it into the model. There's actually a lot of problems that could be existing in your training data and affect the accuracy of your model. So let me just go back and look at the code here. So this is from the docs. This is a classifier problem. So some things, like I said earlier, maybe some things are labeled positive and some things are labeled negative. You create this scikit-learn classifier. You use the function from scikit-learn called train test split to divide into your train and test data. Then you drop it into classifier.fit, x train to y train, and then you're able to make more predictions. And if machine learning and data science was this easy, then everything would be very easy. You just kind of grab your spreadsheet and then drop it in. But as I said earlier, this kind of glosses over how do you get train and test data that you really trust and you feel like it doesn't have like external problems that work their way and undermine your classifier. So kind of one of the more famous issues with your data set is if you've imbalanced labels. So this actually happened to me the first data science project I did on my own. I had a list of houses, and some of them had improved. Some of them, over time, they fell out of repair and were lowered in value. And some of them were so poorly maintained, they were demolished. And so I said, I think this would be a great job for the machine learning. It can look at reports and tell me what happened to the house. And I was surprised. It said no houses would be demolished. And it said very high accuracy. And that's when I started to understand, how do I measure accuracy? Because if you have this kind of problem where 90% of your data is one thing and 10% is something else, and then you measure accuracy as over the whole data set, then the easiest way for your algorithm, for your model to be 90% accurate is just to say everything falls into that blue circle. It's 90%. And I thought that's crazy because the other label, it's 0% accuracy. But this is why it's so important to measure and anticipate this kind of problem of imbalanced inputs and outputs. Another issue kind of related to that is there's several different groups within your data set. And the easiest way for your model to do a prediction is to predict the behavior of a majority group. And in this case, I have the blue dots are doing one thing and the yellow dots are doing something else. But because the blue dots are so predictable and they're all kind of going towards the same direction, your model might easily predict that, develop not just random, but develop some kind of, what am I saying here? So what they're doing here is there is a model being developed of the actual behavior of your data, But because there's different majority and minority groups separate from your problem, this could be an issue. So in the US, we have this issue. We discuss this a lot in terms of we're a very diverse nation, and facial recognition only might work on some people and not on others because it was poorly trained, and it only works on the people that were the majority of the training's data. So this is something you can anticipate as well. If you've done any kind of data science and statistics, this will be familiar to you as well. The problem of missing values. So sometimes the data isn't there, just zero, null, and nan. And in this case, especially if it's manually entered data, having a missing value where someone's just entered like n/a or something like that, it could totally wreck your whole pandas data frame into thinking this column is going to be a string column because someone's put a string in there. And so you're going to want to be able to inspect your table, find these kinds of issues, and either remove these rows from the training data and the test data as well. So you either want to remove these rows from your data or look around them and figure out what the values should be. Then also outliers is a common data science problem. Something just got the wrong reading, and it's just so far out that it's not just because it's a particular group, it's because there's something wrong with your data set, and you need to examine your data to know these are out there. Also, this is a chart that I got recently. Here, if you have a model that's predicting stuff on the time series, the first 1/3, 2/3 of this chart follows kind of a gradual trend, and then there's suddenly a huge drop and things start getting crazy. And this was actually a data set related to the March 2020 coronavirus lockdowns. So that's something that's just totally out of the ordinary, out of the experience for your model. So how can it predict something like that? It can't. And so if you've trained your data on, things in the past, you need to say, halt everything. There's no way it's going to be able to predict what happens next now that we've had something so far out of the ordinary enter our production system. So yeah, these are some different negative things. And you might be wondering, well, this can't be the whole of it. There has to be something I can do to fix it. So this is actually two kind of interesting things. One is just plotting your data. Always plot your data if you're exploring it. And there's so many different columns that you might have some different relationships where you're not sure what you want to plot on the x-axis. But you can try lots of different columns and explore it. For Scikit-Learn, there's something called Yellow Brick, which explores some different things in your data. Here you can see something where, just plotting your data, you can use some different tools to get a trend line. And actually, one thing that I learned a lot when I was doing this is don't just plot it and then try to guess it yourself. Try to use some tools or semi-transparent dots, because something that looks like just a big point cloud field across the whole coordinate field, it could be that several points are kind of clustered along the trend line, and then you just can't tell if there isn't some way to tell the density. Yeah, there's definitely been issues that I've seen where it looks like there isn't a trend until you look at actually kind of like a heat map or some kind of transparency to tell you where the majority of the points really are. On the second half, this is actually a graphic that was part of an actual study that was just done, that was just kind of circulating on Twitter, where they created, this fake data set for some students and statistics students, and they asked half of them, like in group A, tell me what you can conclude from this data. Use statistics, tell me the relationship between the number of steps and BMI. And then the other half of the students, they said maybe you should plot the data first. because then when you plot it, it would look like a drawing of a gorilla, and you would know, wait a second, this isn't real data. And sure enough, everyone that was told to plot the data, or like 95%, maybe one student didn't do it right, but 95% of the students that plotted the data said, there's a gorilla in my data. And of the people that were just given vague instruction to show me some kind of relationship, it was something like, I want to say 20% had actually plotted it and seen the problem. And everyone else in that group who just kind of tried to draw conclusions from tables and models had some really weird conclusions and totally had no idea this was in there. In terms of missing values, Scikit-Learn has, well, first I'll start with the pandas thing. So pandas, if you have your data in a data frame already, if you're like, if this is super familiar to you, if you're like a pandas pro, like, I'm sorry that I'm mentioning this again, but if you think back to the example that I showed here, where there's rows that are empty, and there are rows where the cell has kind of a bad value here. So one thing you can do, this drop NA function will just remove any rows that have a missing value. And you can set that on particular columns as well. And then fill na is something that would fill in those blanks with just like 0 or something, in case you have some blanks and everything else is numbers. If you want to be more scientific about it, Scikit-Learn, and you don't want to drop any rows, Scikit-Learn has this whole series of modules called the impute module, imputers. And it's a fancy term that just means that you're going to estimate what that value could be, or you're going to say, look, I don't want to have my estimate change what the model says. So, like, for example, if we had like an actual BMI data set and some people's age was missing, you wouldn't put the age of those people at 2, and you wouldn't put the age of those people at 100, because it would be strange values. Instead, you can use specific imputers to put it at an average or median value. There are different strategies you can use here that, you're not inventing. It's not up to you to invent a statistics strategy from scratch, right? You can look at a module like this, or if you have a problem like this, look for a module that might help you, and you'll see the different strategies that people have. And because you have this fast iteration, like because you're just running it on your own computer, you could say, well, what happens if I try this imputer? What if I try this other one? What if, I change average, median, and see if that improves your accuracy. There's a lot of different things you can do there. For normalization, I guess you can look at it on a plot and see if you feel like there's something going on with the X and Y axes, and you might want to remove outliers. I worked with someone who if they had enough data for this, they would always remove the top 2% of values and the bottom 2% and the bottom 2% of values from every data set. They would say, what, I don't know the full story of this, but I don't want to predict things that are in these outer ranges. And that's a choice. I don't know. There's different things about that. In terms of algorithms that are available in Scikit-Learn, one thing that people often use is z-score. So probably everyone's heard of standard deviation, where instead of getting your full range of numbers in the original units, it'll turn it into some numbers that will just tell you how close that value is to the approximate center of your values. And if something is several standard deviations out of line, then that would be an outlier. But in terms of these data science problems, my understanding is that statisticians have told people in done this research and said the z-score, which is related but something different. I want to stress that it's a different thing, but look it up. It's definitely recommended by people for this kind of problem of getting the data from its original units into something that's more related to where does something fall in this distribution. And one thing that you have to be aware of is, just like with standard deviation, you know, if you start putting more data into it, you need to figure out, well, where would that point fall on the original distribution? You can't just take, you know, the distribution of your training data and then distribution of your training and test data, or two separate, because those could be two different distributions. You don't want them to be, because then it's more complicated, but kind of keep that in mind, is that when you calculate things about the distribution, it should be when everything is together. Or you should make sure that the distribution is consistent when you add more data. Cool. Imbalanced data, like I mentioned earlier, you have like one thing that's very common and one thing that's not very common, and you want to perform well on both of them. So one thing that I did, I created, one of the first problems I did like this was I created a classifier for dialects in, I think, Arabic. And there are different dialects in Arabic, and some of them are so much more popular than others that it wasn't having a fair evaluation of it. So I had enough data that I could just kind of remove randomly some of the data from training, some of the training data, so that the different dialects had about the same number of samples. Another thing is that the behavior of different classifiers in Scikit-Learn is different. Some of them are more susceptible to imbalanced data than others. So you could try different classifiers and see if you have the same problem. And then Scikit-Learn has this whole section called imbalanced learn, which is basically the more scientific way of what I just described, where in this case, what it'll do is either add more data to your data set by, you know, estimating more sample data or data augmentation, or it'll remove different data, but it'll do it in a more strategic way. So definitely, if you're doing this very scientifically with tabular data, you would want to follow up on this Scikit-Learn project. Another strategy that you could use is changing the loss function. So I guess that this kind of goes back to the second problem that I showed here. So if you had this kind of problem, every time that, or while you're doing the training process, every time that it has a, if you imagine like a linear model, it's trying to fit it to the data, or, you know, as a more complex function. Every time that it has a proposed function, what happens is your Scikit-Learn model is saying, okay, how close was I? You know, is this getting like hotter or colder? Is this more accurate or less accurate than what I did before? And that calculation of accuracy or inaccuracy is one of the things that contributes to the loss function. And what you want to do in the loss function, if you have this imbalanced data, one strategy you could use is you could change the coefficients. Go back to this. So there's something called class weight in Scikit-Learn, where you can say, I noticed that this particular class was not counting as much in the offset, so I'm going to double the weight of that class in calculating loss. And I mentioned that before, is like if you have, you know, different groups and they're not represented equally in your data set, I think this would also be really helpful for if you imagine a situation where it's very dangerous to get something wrong on one of the classes, then you might emphasize that more and say, I always want to know when this is right or wrong, because like a stop sign or something like that. Or let's say there's like a food processing plant and the bag hasn't been closed yet or something like that. Like that would be something where it's like, everything else is interesting to me, but this problem in particular, I never want this to happen, and it'll affect how the model trains itself. And if you kind of adjust these, maybe you could get something that's more accurate and fitting your particular problem. And then I definitely want to emphasize practice in terms of, like, how would you approach these problems if these issues appeared in your data set? How would you solve them? One thing is, Google them, find different things, but eventually you'll find your favorites. Like you'll find, Scikit-Learn has these great issues. Kaggle has these notebooks. Just the more practice you have, the more you'll know who to go to or what page to go to find solutions. And sometimes the practice data set is set up to help you know how to solve this problem. So I have a link here in the slide that I'm sure the slides will be provided later. Otherwise, you can Google this, the credit fraud data set. This is specifically designed. It's not like a actual bank data set. It's just a public demo data set where the fraud, like credit card fraud, regular credit card transactions are happening all the time. And the fraud cases are a fraction of a percent. They're so rare, but you want to catch them. You don't want to say everything is legit. So this is an example problem where, an example data set really, where many people will teach you how they solved it, and you can see which of these solutions make sense to you. Or the next time you have a problem that's very similar, you'd say, you know what, I've seen one of these and I want to look at what they did. And that'll help you assess problems as they come along and anticipate future problems. I think this actually implies to, I wanted to show, this out of distribution thing too, is like I mentioned earlier, you want to understand that your model is not magical or psychic. So if you started seeing unusual data coming in, you could anticipate ahead of time, in this situation, I don't trust the model. Right. That's based on you knowing what data has it seen before, what did I do to the data to make it more normalized, and then being part of that communication, being part of that discussion going forward. So I didn't want to just say, here are some problems, here are some solutions, do what you want. I wanted to have some kind of more interesting stuff that was really interesting that we did when I was in the data science world. And feature engineering is sort of there's a lot of different things that would fall into this category of feature engineering. The main goal is that you're going to add more columns, and those columns are going to add more information that'll inform your model, whether that's Scikit-Learn or anything else, to make the right choice. And the simplest way to think about it is calculations like, for real estate, we would have dollars per square foot or per square meter of your building. And of course, the computer can calculate that very easily. But if you just have one column that's dollars and one column that's square meter and so on, then it's not going to know what am I saying is that the computer model does not know what your columns mean in the real world. So, the other example they had there was different kinds of profits or operating income, things like that. But things that are more complex calculations, especially, that calculation is used by the real estate department or other people already. And you say, the model isn't going to learn it itself. I should just drop that number in there. And so you can run that in your SQL database before your training data is even created, or you can do something in pandas to add more data sets right there and calculate it. Another technique you could use if you have other data sets, like someone's given you their Facebook ID or some kind of ad ID, and you know all this other information about them somewhere else, that's your key to join in that data. And I mean, that's probably what you were planning to do in the first place, but just that kind of idea of, I have some information and I would like to just run and add more information right into it from my database. So that's kind of the basics of it. And one thing that we would do a lot, though, especially with the housing, apartments, and I have a public Medium post where I do Airbnb pricing, is just look at this, for example. Like if I just gave you some coordinates, you wouldn't really be able to use the X and Y coordinates to tell me if this is more valuable or less valuable. Like, but then if we plot them on a map, I just kind of grab this map off the internet here, then that point, the X and Y coordinates, could tell you what neighborhood it's in, could tell you the distance to the nearest transit stop, could tell you, is there a park nearby, shopping mall. And so in this case, I use PostGIS, but you can just use Postgres, or if you're just doing XY coordinates, you could probably get this done just in Python by looking at the coordinates here. But think about how much value is so often connected to what the name of the neighborhood is. And it'll probably inform your model. If it doesn't, then the weight of that column won't really be very much. But the only way for you to know is to think ahead and say, what columns do I think could be important, calculate them, or connect them to other data sets, connect them to OpenStreetMap, connect them to a neighborhood map. And once you've collected that big ball of data and set it up as a tabular format, run it again through your Scikit-Learn model and see if it's improved in accuracy, because it should be able to add information. And there's a package called ELI5. So it's like explain like I'm 5. And it works directly with Scikit-Learn, and it'll tell you how much did each column of your table contribute to the output. And that's good for two things. One, because it'll tell you this was a really good idea to add the neighborhood name. And two, it might tell you, oh, most of my data, they looked at this column that was dollars per square feet, and that actually ended up, basically, I ended up creating something that's very dependent on that column, and I don't want that to happen. You want to inspect this just to know it's looking at all the different pieces of information to make its conclusion and that it's accurate. So that's kind of the overview that I have there. My general thought about these talks is I don't want to like just show lots and lots of code and documentation that people have, but definitely if you look at these slides, I've tried to link to specific projects that you can read to go further if this problem is interesting to you, about how to kind of correct imbalanced data or different strategies for imputing data when it's missing. So, yep, that's the end of this talk, and I'm looking forward to questions if you have them.
Okay, thank you, Nick, for this awesome talk. It is very, very interesting. So we have some questions from the audience. So the first one is from Fight Zaki. The question is, when we use drop NA, fill NA in, I guess this is in Scikit-Learn, right?
Yeah. Oh, this one is in pandas. So typically, before, like when you have the data set, you're going to, before you drop it into fit, you're going to create your data frame in pandas. And just to clarify, so drop na will remove the row if any of the cells are missing, values, and fill-na will, if that cell is missing, replace it with, for example, a 0. So typically my strategy is I don't want to lose data, and I've always interpreted that, in generally I've interpreted that if that cell is blank, that maybe someone meant to write 0. But if you're saying, let's say it was something really important and it's been left blank, you might say, oh, wait, if this is left blank, then it means something's wrong with the data input. I don't want to look at that row at all. Then you would use drop now. Best data visualization model for early. So I mentioned in the talk, I don't have a link to it, but there's something called Yellow Brick. Yeah, Scikit, Yellow Brick, and it does visualization. And another one that I've used is Uber has something called Manifold, and you're able to look at the trends for each column, and it can also do some geospatial data as well. So yeah, I think so. Yeah, I guess to repeat those again, one is Scikit Yellow Brick, and one of them is Uber Manifold.
Okay. Sorry, what is the first one? Is Scikit Yellow
Brick, like
Brick.
BRICK, like
Okay.
follow the yellow brick road. Kind of, I don't know if
Okay.
you have that there.
Okay. Cool. Now for the third question is another one from Vaishaki. His question is, when we use drop NA instead of fill it with some value, it is just depend on the researcher, or there are some standard of when to use drop NA or when to use fill NA with some value. So I think, yeah.
Yeah, I think it's similar to, like I said earlier, you can also use the Scikit-Learn imputer section. And so there's several different strategies. And then there's not, the reason there's so many strategies is because there isn't always one that always works. And so this, you might want to, while you're building your pipeline, say, okay, I'm going to try this first. I'm going to try this second. And then I'm going to try this third. I'm going to run everything through and see, did one of these improve my accuracy? And my general thought, I like to do fill-na instead, because if I don't want to lose training data, like there could be, it depends definitely on your problem, but I usually just try to avoid losing the precious training data.
Okay, thank you. Now there is the last question from, sorry, I will hide this. The last question is from Fendi Gunawan. So his question is, what should we do if the nature of the data itself is imbalanced? For example, there is less likely people will call customer service to say thank you. They most likely call CS to complain about something.
Yeah, that's a good question. It's a good question, and it's good that like you understand the problem and you're anticipating this is going to be the case. No one is going to call and give, their specific product ID and then say it was amazing. I just wanted to talk to somebody about it, right? It's a good, you're definitely anticipating this problem. So first, if someone asks you to build the classifier for this particular problem, you could report back to the manager saying, I'm just going to see what percent are positive and what percent are negative, just so you know what we're setting up here. And then the example that I gave, there's a link in the slides that is saying there's an example of the credit card fraud, which is less than 1% likelihood. So for that, they have some specific recommendations on that page that I'm not going to remember right now. So I'm not going to remember their recommendations right now, but it depends on different It depends on which algorithm is used. So I know, like, for spam detection, people typically use a Bayesian model. And you might say, well, why is that? And said, well, people have tried many dozens of different algorithms, and Bayesian works really well. And so there could be different explanations for that, but you just have to go down that route of saying, okay, if there's something like spam detection or fraud detection, what algorithms do people use for that? And how do they get over this imbalanced data problem? And Scikit-Learn has some different resources about that for sure.
We also have one more question, so
Great.
we still have time for. So the question is from Triangolo Wiwadinata. The question is, in measuring accuracy of the model, do you have guidance on proportion of splitting train versus test? So,
Yeah, so I think the standard that most people use is 70-30, or I guess 80-20 probably is very similar. I would like to see a situation where, what if you were so confident about the model? This is like in the future, but what if you were so confident in the model that, your test set could be larger, right? Because when it goes into production, it's just going to be test and production all the time, right? So, just while you're doing these problems the way that people are doing them now, we just try to do 80-20 or 70-30, like you said. But I'm hoping that over time, we're going to put more in the test set, because that's how you're measuring if your project works or not. And, maybe it's more complicated than that, but that's something that I've just been kind of exploring and hoping will change over time.
let's see. Okay, so I think there is no more question. So thank you very much, Nick. It is early in the morning for Nick because he is in
But yeah,
United States.
thanks for having me, for sure.
So thank you very much for participating in this session, and also for the all participants. Thank you very much for attending this session. Okay, allow me to close the session and see you guys in other session.
See you.